Okay, let's get right into it. What we're looking at here isn't just a business plan. It's really a playbook for a whole new kind of power. A power that isn't based on land or armies, but on controlling the entire physical stack of intelligence itself. We're calling it the Musk Doctrine, and it operates on a pretty simple, almost wild premise. If you want to own the future of AI, you first have to own the physical stuff that makes it all possible. This whole story is about a massive shift from software to silicon, from just writing code to controlling atoms.
And this quote right here, this is the heart of the whole thing. For a minute, just forget all the romantic ideas about elegant algorithms. The new race is all about physical matter. We're talking about factories, power plants, cooling pipes, the whole shebang. The core idea is that software is now officially limited by physics. This one sentence completely reframes the AI competition, dragging it out of the abstract cloud and down into the dirt, the water, and the electrical grid. This is where the real fight is going to happen. And this infographic shows you the fundamental conflict, the collision course we're on. On one side, you've got the demand for AI compute, and it's shooting up on this just insane exponential curve. It's like a beast with an infinite appetite. But on the other side, you have the growth of our physical world, our energy grids, our power stations, and that stuff grows slowly, linearly. You can't just snap your fingers and wish a gigawatt power plant into existence. Musk's entire doctrine is built around that single point where these two lines crash into each other. That glowing red spot, that's not just a bottleneck. It's the physical ceiling for AI progress on planet Earth.
So for years, the big question in the industry was always, can we physically make enough chips? But Musk is arguing that the game has totally changed. When TSMC, the world's biggest chip maker, recently said they were worried about a chip glut, an oversupply, Musk agreed, but for a completely different and frankly terrifying reason. He doesn't think demand for AI is slowing down at all. He thinks our ability to literally plug the chips in is hitting a brick wall. The problem isn't making the silicon anymore. It's finding a place on Earth that has enough power and enough water to actually turn the darn thing on.
And this is where it gets really, down and dirty. These aren't just theories. When they were building the Colossus supercomputer in Memphis, they were right next to high voltage power lines. But it still would have taken a full year just to get hooked up. So what did they do? They flew in dozens of methane gas turbines to create their own temporary power plant. It's crazy. We're talking about a global shortage of high voltage transformers, those big gray boxes at substations. And cooling? Oh man, the whole industry is moving from air cooling to this much riskier liquid cooling, which needs a mind-boggling amount of water. We're talking up to 5 million gallons a day for one large data center. That's a small town's worth of water, just to keep one AI from melting. These are the hard physical walls we're running into.
So if Earth itself is the bottleneck, what do you do? Well, the proposed solution, like you see here, is as radical as it is simple. You just bypass Earth. You escape the terrestrial ceiling. Why fight for scraps of power and water on this congested planet, held back by grids and permits, when you can just leave? It completely reframes the problem from one of resource scarcity to just a problem of location. And this brings us to the official term for this idea, orbital data centers, or ODCs. Now, this isn't just about strapping a server to a rocket and calling it a day. This is a whole new way of thinking, a new architectural paradigm. It's about designing a computer system from the ground up to take advantage of the very unique physics you find in space. It treats orbit not as a place for GPS and communication satellites, but as the ultimate data center location.
And when you just look at the raw physics here, well, it's not even a fair fight. Let's break this down. On Earth, you have to constantly fight thermodynamics. Use huge fans and millions of gallons of water just to move heat around. That's convection. In space, you have the ultimate heat sink, the near absolute zero cold of the void. A data center can just radiate its heat away passively, for free. What about power? On Earth, you're fighting for a slice of an old, strained grid. In orbit, you get unfiltered 24/7 solar power that's up to 8 times more efficient than what hits the ground. And land? It's literally infinite. From a physics and resource perspective, Earth just can't compete.
Okay, but how does this idea go from sci-fi to a real engineering project? It really comes down to 3 key pieces that Musk has been building for years. First, you need the truck. Starship is the only rocket in history designed to launch the sheer megatons of mass you'd need to build entire industries in space, 200 tons in a single flight. Second, you need the network. The new Starlink satellites aren't just beaming internet. They're nodes in a 4 terabit per second laser mesh, a literal brain in orbit, letting these data centers talk to each other and the ground instantly. And third, the goal. This isn't just about launching a few servers, it's about creating a totally self-sustaining grid of intelligence that doesn't need Earth for anything.
So we've covered the where, orbit. Now let's talk about the what, the silicon itself, the engine. And it's so important to understand that AI compute has two very different sides, which you can see in this pyramid. At the very top, you have the models themselves, like Grok. In the middle, you have the brutal, power-hungry process of training those models. That's where partners like NVIDIA come in. But the foundation, the biggest part of this pyramid by far, is inference. That's the act of actually running the models in the real world. And that's where Tesla is building its own kingdom.
To really get a feel for the scale of the training process, just look at this number, 100,000. And get this, that's not the total. That's the starting number of NVIDIA H100 GPUs for just one supercomputer, Colossus. It's a monument to brute force, and it eats up more electricity than some small countries. Every single one of those GPUs costs more than a new car. You're talking about billions of dollars in hardware just to get the training started. This is the heavy artillery you need to forge a frontier AI model from scratch.
But here's where the strategy gets really, really smart. Musk isn't trying to beat NVIDIA in a head-to-head fight in the training world. That would be crazy. Instead, he's pulling a classic flank maneuver. He's using NVIDIA's best-in-class hardware for the heavy lifting of training, but at the exact same time, he's building a totally custom secret weapon for the much larger, more cost-sensitive world of inference, the part that runs inside millions of cars and robots.
And here's just how disruptive that flank attack could be. These are the claims for Tesla's upcoming AI5 chip, compared to NVIDIA's top-of-the-line Blackwell GPU. Less than 10% of the cost, 3 times the energy efficiency. I mean, think about that. NVIDIA's chip is a $30,000 700-watt monster that needs its own liquid cooling system. Tesla is claiming they can get similar inference performance in a tiny little package that fits inside a car and just sips power. This isn't a competitor, it's a completely different species of hardware.
And just in case you thought, oh, this is probably just some side project he delegated to a team of engineers, well, this quote from the man himself tells you everything you need to know. This is a personal obsession. The same person setting the grand strategy for escaping Earth's energy limits is the same person literally dreaming about transistor layouts. That level of personal focus is what makes this entire doctrine so formidable.
Let's see how this builds out into this just relentless roadmap. This isn't a one-off chip, it's a machine that keeps producing. Look at the pace. HW4 in 2023 laid the groundwork. Then comes HW4.5, this crucial interim step with a 3-chip system. Now, why 3 chips? Triple redundancy. In a robotaxi with no driver, the system can't just fail, it needs 2 other systems to check its work and vote on the right thing to do. Then comes AI5 in 2027, the monster chip. We're talking a 40x performance leap, aiming for true, unsupervised autonomy. And right on its heels, AI6, doubling performance again, with the goal of creating a unified AI fabric, a seamless network of AI brains working as one. This isn't a normal product cycle, it's a blitzkrieg.
So we've covered the location and the design, but the final layer of this strategy, the deepest, widest moat you can possibly build, is owning the factory itself. It's not enough to design the chip. To be truly sovereign, you have to control every single step of its physical creation, from a blank piece of silicon to a finished product. This is where the doctrine goes from just ambitious to almost unassailable.
To really get why this is so huge, you have to understand that the normal chip supply chain is dangerously fragmented. First, you have logic fabrication. This is where the brain of the chip is etched onto silicon with almost atomic precision. It's an incredibly specialized process, and it's dominated by just a few companies in the world, like TSMC in Taiwan. Right there, boom, that's your first major dependency, and it happens to be sitting in a major geopolitical hotspot. But a brain is pretty useless without memory, right? So next, you have to go out and source specialized high-speed memory from completely different companies, like Samsung or SK Hynix in South Korea. They have to be physically attached to the logic chip, which is a super delicate process. And there's your second major dependency, a different company in a different country, creating another place where things can go wrong or get delayed. And then finally, you have advanced packaging. This is the incredibly complex process of squishing the logic and the memory together into a final working package that won't overheat and destroy itself. This is a massive bottleneck for the entire industry, and guess what? It's often outsourced to yet another group of specialized companies. So to make one advanced chip, you're trying to coordinate between at least 3 different vendors across multiple countries. It's a logistical nightmare.
And Musk's proposed solution to this whole nightmare is the TeraFab. You can see the vision right here. Just collapse that entire fragmented global supply chain, take it from a slow, inefficient multi-country process, and bring logic, memory, and packaging all under one roof. This wouldn't just protect the process from geopolitical shocks, it would let them co-optimize hardware design and manufacturing in a way that's never been done before, slashing development time from years down to months. But why on earth would you take on such a monumentally expensive and difficult project? Well, this number. This is why. The internal demand projected for Tesla's cars, the Optimus robot, and whatever other AI products they come up with is between 100 and 200 billion chips a year. There is no external supplier on the planet equipped to handle that kind of volume from a single customer. At that kind of scale, building your own sovereign production platform starts to look less like a crazy ambition and more like an absolute operational necessity.
So when you put all of it together, this is what you get: the doctrine of compute sovereignty. It's about building a fortress. It's about pulling away from geopolitical hotspots like Taiwan. It's about shrinking the time it takes to go from an idea to a chip in a car from years to months. It's about optimizing everything from the transistor level all the way up to the final AI application. And ultimately, it's about building a physical, atom-based moat that no competitor can cross by just writing better code.
And that leaves us with this final, really crucial question. This entire doctrine we've just walked through, from data centers in orbit to vertically integrated factories, it's all built on one core belief: that artificial intelligence is becoming the fundamental currency of national and corporate power. So if that's true, the question isn't just about building better cars or more capable AI. It's about the immense, almost frightening value of being the one entity on Earth that controls the mint itself.